So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic electrolysis. So guys, this video will be about the Faraday's law of electrolysis. So in short, to stay till the end of this video, guys. And also, you already know that at any point where you feel you want to answer any question here from this video, you can always pause the video and try to get the answer to the question even before we provide the answer thereafter. So let's quickly start with the first question, guys. The question here says, calculate the volume in cm cube of oxygen evolved at standard temperature and pressure when a current of 5 amperes is passed through acidified water for 193 seconds. So we are given the value for the farads and the molar volume of a gas at standard temperature and pressure. So let's quickly go ahead and solve these together. We're going to zoom into our workspace here, and then the first thing to do is for us to understand what actually happens in this situation where oxygen will be liberated. So actually we need to understand that first of all, in the cathode there is a reduction, so whereas in the anode there is oxidation. So since there is oxidation in the anode, we need to also understand that oxidation is electron loss, right? So this is what actually happens. Hydroxyl will lose an electron and then gets to form this, and then oxygen is liberated. So this is what happens at the anode where oxygen gets liberated. So this is the first thing we need to understand. But then we know that we don't need to have a negative sign here in this expression, so we are not going to have minus an electron, so it doesn't show well of this representation. So we are going to actually bring this electron over here, so this will now become H2O plus oxygen gas is liberated plus an electron. But guys, notice that this expression is not balanced, so we have to go ahead and balance it. So how do we do that? So we need to check out how we can balance not just the elements but as well the electrons. So for a balanced expression, this is going to be 4 hydroxy ion, so to yield 2 of this, and then O2. But then since the number of electrons here is 4, you're going to also have 4 electrons here. So guys, this is more of a balanced expression here. So we have this, oxygen is 4 here, and then oxygen is 4 here, that's 2 times oxygen here, and then 2 of this here, that's 4. Then hydrogen is 4 here, and that's 2 times 2, that's 4 here. So we have 4 electrons here and we have 4 electrons here. So this expression is balanced at this point. So guys, the next thing we are going to do, now that we've gotten the balanced expression for this, is to know what the charge is here. So guys, I'm going to wipe all these and rewrite the expression at the top side here again. So let's have this expression here again. All right, so having this now, let's recall that Q, which is the charge, is going to be IT, where I is the current and T is the time. So if we have this expression, then the current given to us from the question is 5 amperes, then times the time given to us, which is 193 seconds. So we're going to go ahead and bring up our calculator and solve this together. So guys, here, let's do 5 times 193. So that's 965. So this would be 965 coulombs. So that's the charge here. All right guys, so since we have the volume of gas at standard temperature and pressure here to be 22.4 dm cube, and then guys, we have 4 electrons here. So it means that here 22.4 dm cube will be 4 times the Faraday's constant, that's 96,500. So now guys, if this is the case, we are still going to, since we have gotten this in columns as well, so we are going to ask how many dm cube do we have in 965 columns. So guys, as usual, we are going to cross and multiply. Let's say this is x dm cube. So when we cross this, we are going to have x dm cube to be 22.4 dm cube times 965 columns over 4 times 96500 columns per mole. So here guys, we are going to solve this together. So 22.4 dm cube times 965 columns. So this will be 21,616. So let's go ahead and write 21,616. So this will be over 4 times 96500. So guys, that's a 386,000. So guys, when we divide this, let's see what we'll have. 21,616 over 386,000. So guys, x dm cube will give us 0.056 dm cube. But guys, notice that from the question they said we should find the volume in cm cube. So simply going to find the volume in cm cube here. So that will be, let's go ahead and wipe this. So that will be, like we know, multiplied by 1000. So this will be 56 cm cube. So guys, that's the answer to this question, and that's option A here, guys. So let's go ahead and wipe this, and then let's consider the next question. Question number 2. So guys, question number 2 here says, how long would it take to deposit 0.08 grams of copper from copper chloride solution by passing a current of 0.5 amperes? All right, so guys, for this we're going to first of all show what happens here. So first of all, we know that since this is a positive ion, it's going to happen at the cathode. So it's going to be this plus 2 electrons, that's Cu. So this will be how the copper ion is going to discharge to give you the copper as solid. So guys, having taken note of this, we know that we have 2 electrons here. So said, how long will this occur? So first of all, in order for us to get the charge in coulombs, we are simply going to make use of our Faraday constant here, because of course we know that the atomic mass of copper is 63.5 or 64. So we know that 64 grams of copper will yield, since we have 2 electrons here, that's 2 times the Faraday's constant, and that's 96,500. So whereas if this is the case, guys, we have 0.08 grams of copper. So what will be the charge here? 0.08 grams. So guys, remember to always put the units at the side where they correspond. So this is 64 grams corresponding with the unit here, 0.08 grams of copper. So what is it going to yield? That will be our charge here. So guys, let's go ahead and do this together. We are going to cross this, and we're going to have our Q to be 0.08 times 2 times 96,500. Oh, sorry for this, 96,500. So over 64. So let's go ahead and calculate this. So you're going to have 0.08, and then this multiplied by 2, and then this multiplied by 96,500. So this is 15,440. So you're going to divide this by 64 here, and this is going to be 241.25, 241.25. So guys, Q is 241.25, but we know that Q is equal to IT. I hope you've not forgotten this expression, so you have to always recall this. So now that we have this, we can go ahead and wipe these other parts. So since Q is equal to IT, what next do we do? We want to know the value for the t, that's how long it will take, that's the time. So we are going to make the t the subject of this expression. So t is going to be q over I. So we know that q is 241.25, and then I is the current, which is 0.5 amperes. So remember that t is going to be in seconds, so you're going to divide this by 0.5, and that's 482.5 seconds. So guys, this is 482.5 seconds. But then the options given to us are all in minutes. So to convert this to minutes, we'll simply divide by 60. So, you know, converting seconds to minutes, you divide by 60. So all these are simple conversions we should know. So when we do this, we are going to have 8.04. So that's approximately 8 minutes here. So t becomes 8 minutes, and that's the answer to this question, guys. So that's option C here, 8 minutes. So we'll go ahead and wipe this, and then we'll consider the next question, guys. And then the next question, guys, is question number 3 here. The question here says, given that M is the mass of substances deposited in an electrolysis and Q is the quantity of electricity consumed, the Faraday law can be written as A, M equals Q over Z, B, M equals QZ, C, M equals Z over Q, D, M equals Z over 2Q. So guys, the answer to this question is option B here, M equals QZ. So that's it for that question. Let's consider the next question, guys. That's question number 4. It says, calculate the quantity of electricity passed when 0.4 amperes flows for 1 hour 20 minutes through an electrolytic cell. So guys, we want to consider the quantity of electricity. So let's zoom into our workspace here and solve this together. We want to consider the quantity of electricity. So we know that Q is equal to IT. So since we've established this, Q is equal to IT, we want to find the quantity of electricity, which is Q. And already we have I and we have T. So I is the current, which is 0.4 amperes. And then T is the time. Remember that this time should be in seconds, but then we are given 1 hour and 20 minutes. So 1 hour is 60 minutes. So we are going to do 60 minutes plus 20 minutes. That's 80 minutes. So this 80 minutes, we are going to multiply it by 60 again to have this in seconds. So 80 times 60, and that's 4,800 seconds. So T is 4,800 seconds. So what's Q now? Q is going to be I times T. I is 0.4, then times 4,800 here. So we are going to get Q to be 1,920. So guys, that's option B here, and that's the answer to this question. So let's quickly wipe this off, and then let's consider the next question here, guys. The next question we have here is question number 5. So the question says, if the cost of electricity required to discharge 10 grams of an ion, this is a trivalent ion, guys, and we said if the electricity required to discharge 10 grams of this ion is 20 naira, how much would it cost to discharge 6 grams of ion Y with a 2 valence? This is a divalent ion. So guys, we are given the Faraday's constant and we are given the atomic masses of these ions. So we are going to simply go ahead and solve using the information we have here. So first of all, we know that for this trivalent ion, the expression is going to be such that there will be a discharge by this. So now if this is the case for the trivalent ion, then for the divalent ion being Y, it's going to be this plus 2E, and this is how it will discharge. So this is how X will discharge, and this is how Y will discharge. So having this knowledge, we are going to see, since we are given the atomic masses, the atomic mass of X, which is 27, will require 3 times the Faraday's constant. That's 96,500. So if this is the case, then 10 grams of this X, what will be the charge that will be required to discharge 10 grams of X? So we don't know. Let's call this Q here. So we're going to cross this out, and then we are going to have Q to be 10 times 3 times 96,500 over 27. So we're going to punch our calculator here. 10 times 3 times 96,500. So this will be divided by 27. So let's go ahead and wipe this part, and then let's keep this aside. The charge for X. So for Y, let's go for Y now. So we are going to say for Y, we are given the atomic mass of Y to be 24. So this means 1 mole of the Y, which is this atomic mass of 24 grams, will actually require 2 times the Faraday constant. That's 96,500. So if this is the case, then 6 grams of the Y, as given in the question, will require what? So let's also call this charge for Y. So let's go ahead and multiply out. So this will now give us 6 times 2 times 96,500 over 24. So when we calculate this, 6 times 2 times 96,500 is going to give us this. So when we divide it by 24, it's going to be 48,250. So let's write it down here. So the charge for discharging 6 grams of Y is going to be 48,250. So let's go ahead and wipe this part. Let's go ahead and wipe off this. So finally, since we already know the charge for X and the charge for Y, we're going to say if actually it takes this charge to discharge, it takes 20 naira for this charge. So how much will it take for the charge for Y? So it means that 107,222 2.22 requires 20 naira. Then 48,250 is going to require how much in naira? So we don't know. So let's call this X now. So we're going to cross this, and then the X naira is going to be 48,250 times 20 over 107,222.22. So this will be, let's calculate this out, 48,250 times 20, and this will be divided by 107,222.22. So let's see what we have here. So this will be 9 naira here, right? And that's option C here. So guys, let's go ahead and wipe this. That's the answer to this question, and that's option C. So we are going to consider the next question, guys. That's question number 6 now. So let's check out the question number 6 here. It says, given that M is the mass of a substance deposited during electrolysis and Q is the quantity of electricity consumed, then Faraday's first law can be written as, so we are taking E to be electrochemical equivalent. So we are going to have A, M is equal to EQ, B, M is equal to QE, C, M is equal to E over Q, and then D, M is equal to E over 2Q. So guys, the answer to this question is going to be option A here, M is equal to EQ. So let's check out the next question. That's question number 7. It says, calculate the mass of silver deposited when a current of 1.8 ampere is passed through a solution of silver salt for 90 minutes. So guys, for us to calculate this, we are going to zoom into our workspace here. So what we want to find is the mass of silver that is deposited. So we are given already the atomic mass of silver to be 108 farads. So guys, with this, we know that this charge of silver will be such that will have this to yield silver solid. So since we have this here, it means that the 1 mole of silver, which is the atomic mass here, 108 grams of silver, is going to require just 1 times the Faraday's constant. So that's 96,500. So since it's this way, let's also say we are looking for the mass of silver here, right? So what mass of silver now will now require the charge. So this charge is going to be 1.8 times the time. That's 90 minutes. 90 minutes is actually 90 times 60 seconds. So remember that this is the charge here for the farads, and then this is the calculated charge here. This is because we know that Q is equal to IT, right? So this is the Q here, that's IT, and having that we have IT. I is the current, and then T is the time. So we are given the time in minutes, we have to convert to seconds. So that's why we have this. So this will be the mass here. Let's call this mass in grams. So if we have this way, we are simply going to cross this out, and then let's say the mass will be 108 times 1.8 times 90 times 60. So this will be over 96,500. So let's go ahead and calculate this. This is 108 times 1.8 times 90 times 60, then all these over 96,500. So guys, this is 10.878. So this is approximately 10.88 grams. So that's it for this question, and the right answer to this question here is option B. So we are going to check out the next question, guys, and that's question number 8 here. So the question here says, calculate the quantity of electricity obtained from 2 moles of electron. So guys, that's actually very simple. 2 moles of electron will have 2 times the Faraday's constant, that's 96,500. 96,500. So 2 times 96,500 is going to be 193,000. So this is 193,000. So this is one of the questions you can use as a bonus here in your chemistry. So let's just quickly wipe this off, guys, and then let's solve for the next question. So the next question here is question number 9. It says, if a given quantity of electricity liberates 0.65 grams of zinc ion, what amount of mercury ion will be liberated by the same quantity of current? So guys, we want to first of all find the quantity of current here for the zinc ion. So let's simply zoom into our workspace here. So in order for us to find the quantity of current here for the zinc ion, first of all, we are going to write the expression. We know that this is zinc ion, and definitely there will be 2E to discharge, right? And this will give zinc in solid form. So now if we discharge this zinc this way, it means that we have 2 farads for the mass of zinc here. So for each mole of zinc here, 1 mole of zinc here will require 2 farads, and that's 1 mole of zinc is 65. That's the atomic mass of zinc. So it will require 2 times the Faraday's constant, that's 96,500. So with this, we want to find the charge now for the mass of zinc given to us, which is 0.65. So what will be the charge Q here? So we're going to cross this out, and then we're going to say Q will be 0.65, which is this times 2 times 96,500 So this will be over 65. So 0.65 times 2 times 96,500 will be this. So when we divide it by 65, we're going to have 1,930. So Q is going to be 1,930. So let's go ahead and wipe these other parts. So let's note that this is the quantity of charge required for the zinc ion. But then for the mercury ion, if I have mercury here, it's a divalent ion, therefore I'll have 2E here to discharge it to mercury. So with this, I definitely know that the mass of mercury, atomic mass of mercury, which is 201, as given to us here, we will require 2 times the Faraday's constant, that's 2 times 96,500. So in this case, I have my charge, the second charge given here, and that's 1,930. So I'll be looking for the amount, which is the mass here. So let's call this mass in grams. So I'll go ahead and wipe these lower parts here. So, and then to get the mass, we're going to cross this out. So let's say mass will be, so this times this, 201 times 1,930 over this, that's 2 times 96,500. So guys, we're going to do 201 times 1,930. This is 387,930. So this will be over 2 times 96,500, and that's 1,193,000. So guys, with this, if we solve for this, 387,930 over 193,000, you're going to get 2.01. So the mass of this in grams, or the mass of mercury in grams, that will be liberated by the same quantity of current, is going to be 2.01 grams. So guys, that's the answer to this question, and over here that's option D. So we are wiping this off, and let's consider the next and the last question here, and that's question number 10. Guys, we're coming to the end of this video. So we have the cost of discharging 6.0 grams of a divalent metal X from its salt is 12 naira. What is the cost of discharging 9.0 grams of a trivalent metal Y from its salt under the same condition? So guys, here we have that X is a divalent metal. So let's zoom into our workspace first. So we have that X is a divalent metal, right? Which means X is going to be such that we have this, and it's going to discharge by this to have x here. So if this is the case, we said now we are given the atomic mass of x to be 63 actually, so which actually indicates that 63 grams of x is going to require 2 times 96,500. So guys, I believe you should have been familiar with this by now. So the next question is, now what's the charge that will be required for the 6 grams of x? So let's call this Q for x. So we are going to cross these out, and then the Q for x here is going to be 6 times 2 times 96,500 over 63. So guys, this will be 6 times 2 times 96,500, and this it's divided by 63, and we're going to have 18,380.95. So we're going to write this down here separate. So let's call this 18,380.95. So we're going to go ahead and wipe this for the x, and then also do the same for y. So for y, we have that y is a trivalent metal. So since y is a trivalent metal, it's going to be such that y will have the valency of 3 plus, since it's a metal and it's trivalent. So this will require 3 electrons here to discharge to become y here. So with this expression, we know that the atomic mass of y given to us here is 27. So which means 27 grams of y will actually require 3 times the Faraday's constant. And then since we are told to find the cost for 9 grams, so we are working with 9 grams of y. So what will be the charge here? Let's call this Q for y. So let's go ahead and cross this out. So to find the Q for y, it's going to be such that we'll multiply this by this. And then we'll divide by 27. So we're going to have 9 times 3 times 96,500. So we'll divide this by 27, and then this will give us Q for y to be 96,500. So let's go ahead and wipe these off. So having Q for y to be 96,500, we are going to establish the costs now. So since the Q for x, which is 18,380.95, will require 12 naira, so this is 18,380.95. This charge actually requires 12 naira. So how much will 96,500 require? So we don't know, so let's call that x naira. So we are going to have our x to be, when we cross this, we're going to have 96,500 times 12, and this over 18,380.95. So guys, let's go ahead and calculate this. This times 12 now divided by 18,380.95. So this will be 63. So it means that X naira is 63 naira. So this will be the amount that will be required to discharge 9 grams of the trivalent metal Y. So that's it for this question. That will be the end of this video, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So guys, we want to also use this medium to encourage you to join our YouTube channel community by clicking on the join button below, guys. And that will be all for today, guys. Thank you once again for watching this video. See you on the next one.